Hello. We have reached over 5,000 subscribers. Thank you very much. I see that we have a big interest in animatronics. Now we're going to get into part 2 of this animatronic build. And I'm using SketchUp 2017. On this video, you'll see me basically just lay everything out. I'll work on all of it and redo a lot, and you'll see here how I go about doing it. And once again, this is SketchUp 2017, and I'm doing the different recordings so you can see how I'm clicking the pull down bars and activating and deactivating like components. And like components are like when you make an object, you can highlight the entire object and select it, and it will lock it into a component, and that'll be a box. And then you can have another object and you can do the same thing, and you can put those two components together without joining together. So you can unlock one and work on it, but if you unlock both of them, they'll connect, and that can be kind of a pain sometimes. Here you'll see that I'm working on the lip mechanism for the upper lip, and it has an axis, and all these movements that I have a rotational axis, and it's, you have the eyelids, you have the jaw, you have the lips, you have the lower lip, you have the brows, and they all have this. What I'm making is an axis, and it's basically where the hinge mechanism will rotate. But that's what I've been working on throughout the whole process of designing. Each movement will have a servo. Now, even though that some of the so-called objects that I'm designing, like the double fork of the lip, even though it's double, it's just still one movement, but it'll give the illusion to when you have the center hinge mechanism moving, it'll make the lips do like the a more realistic shape of moving it. These axes that I'm designing are like maybe a little bit longer than probably 50 millimeters, maybe shorter, 40, but they all have a threaded rod going straight through. It's just like the eyes and the eyelids. They have a long rod. I mean, they're probably uh, maybe 22, maybe 30 millimeters at the most. But then they'll have a nut, a lock nut on the end of it. Well, I want to be able to, when I'm designing this, so I can get to that nut, so I have room, to screw in place. And if it's like, for instance, if it's behind the arm of the jaw, I can't put a screw, or I cannot put a long rod through there unless it's modular, already designed to where I can attach it first and then place it there when the jaw is already attached. And there's just different things about this. Is what I have to design to overcome any kind of obstacles. And the thing about designing animatronics that you know, I've been doing this for a little while, really got into it, just when you do an old school way, you're sitting there and you're carving these blocks, or you're bending wire, or you're sculpting something, and you're casting it to be a certain length, or it's hands-on work. But with digital design or CAD, you can kind of like design it in 3D space. And this is what I'm doing. I'm designing these parts, and I can I can get it to work to where I can move it and check, well, is it going to bump that servo behind that jaw? So I have to, design it where the servo is on the jaw, and I can rotate the servo and the jaw to see if it's going to bump into anything. And if it does, I have to make changes. Or, it's just things like that that you have to work through. It's something that's never been designed before, so you have to make adjustments. And here I'm just working on the lip mechanism and the center lip. Even though that these are kind of bulky right now, I'll reduce the size later and you'll probably see that. And then like you see here, it's bumping into the eyelid. And once again, you'll see me remove a whole piece and pretty much like redesign this whole eye mech or eyelid mech mechanism completely. And it's just a part of it. Like we saw it bump into the upper lip, so I need to make adjustments. But I'm wanting to make sure you'll see it also that I'm gonna have the eyes on a flat plane, and then when I'm working on the jaw, I can build off of that flat plane. And there's times where, I'll struggle with a part, even though I have to manipulate it, and, that's just part of it, you know, or it's not doing what I want it to do, or it's not, level. Like I'll grab a part earlier. Well, yesterday I did a part and I noticed that my servo had a slight tilt to it. But then I looked at it and it did have a tilt, but it made all of them have that tilt because they were copied. So it copied all of it. So I had to physically go inside the component and level them all out. And you know, sometimes and a lot of times I'll make mistakes like that. Like I'll accidentally move something and I'll say, what happened? And then I'll find out later that I have to click, the undo button a few times to go back and correct what I messed up. But it does happen. And once again, I appreciate all the thumbs up and the kind words in the comments. You know, I really enjoy this. I've been doing this art for a long time, and it's a passion you really get out of. In the world of 3D printing and just art itself, is when you make something and you have it printed and especially when you get it to move. It's just a wonderful feeling, and it's like, I made this. And I want y'all to be able to experience that too. But once again, thank you for all this, the shares and and just overall the all the subscribers, and I know everybody has the same interest that I do. But and as soon as I get the Patreon set up, I'll have STL files available for this, and I'm probably going to be having some other smaller ones available also. And then that way you can print it, and I'll have a listing of what servos to get, and then that way y'all can actually do hands-on and see this thing move, and then it will. I'm telling you, when you see something like this move in front of you, it will. You'll start to think, and it's just a great feeling. But I've been contacting a lot of suppliers that for all the parts that I use in these animatronics, and there's certain types of servos and there's wires and it's just overall supplies for these certain things that I design. And I just want to make sure that these parts are available, and or or do I have to like redesign something so I can find an existing part available? But that's what I've been working on. It's just getting everything set up with Patreon. You know, I got an account, and but I have to do other things, and it's been growing. And I've been working on this animatronic, and I have other animatronics I'm working on at the same time too. But I appreciate y'all's patience. Another question someone asked me about that, could I just solder the wire on the servo to make it reverse? And you can do that. And you can do it and, save a little money and not just buy, a reverser. But the reversers are so cheap, and that way you don't have to break down a servo and risk messing that servo up, especially if the servo is expensive. And there's other options. You can buy a programmable servo, which is really high dollar. I mean, some of those are almost, if not over $100, where you can go in there on your computer and change it, reverse the, the rotation of the servo. But now, with reversers, you can get 10 of those for like, maybe $1 a piece, for like $10, $12, and you can have, a handful of, reversers. They used to sell them on Y cables already made. That way you just buy the Y cable reverser and just do it. But now they have them separate, the Y cables, and then they have reverser cables. Somebody's comment was, do I tilt the eye to kind of get rid of this uncanny valley? And I do. I prefer to tilt my eyes. And you'll see later at the end of the video the reason why I tilt. The smaller ones I just can't tilt because they're just so close together. But I'll explain that later on. But yeah, I like the the tilted eye look because it doesn't look like straight. I guess the uncanny valley look. Yeah, and another question I had was why don't I use Fusion 360? Well, Fusion Fusion 360 is good. I mean, don't get me wrong. I just I've tried it and I have played around with it, but it's just a different format that I'm used to, and y'all can agree with me. You get used to a certain software, you get kind of spoilt to it, and then you throw in another software. But you know, I played around with Blender for years, and then it was let's say Sculptress I played around with for years and loved it so much I wanted ZBrush and got ZBrush, but ZBrush is huge, and it's a learning curve also, and it's different than Sculptress is, and it's different than Blender Sculpt. But like like in CAD or like in this SketchUp 2017, I am limited on certain things that I can do. I couldn't do a sculpt of some creature in ZBrush, and it's no way for SketchUp to carry it. But yet you could put the sculpt in Fusion 360, and that's a plus. And it's just you know, uh, you get used to a certain format, and when something is thrown into it different, it's just hard to get, used to it. But there are a lot of good softwares out there that you can use to make animatronics. I've always wanted to work with SolidWorks, but it was so expensive, and it's just like ZBrush. ZBrush is expensive. I mean, and I technically I'm a starving artist, so it's hard to get some of them high dollar softwares, and even though this SketchUp 2017 is free, and some of the new versions of SketchUp is expensive, and there's just some things I just can't afford. With this whole YouTube channel, this animatronic channel that I put together, I'm trying to keep costs low because I want you guys to be able to experience what I experience, and and I've put a lot of research on what servos to get and which ones not to get, and some to stay away from. But and I try to keep costs down so y'all can afford this, because this can become quite expensive, because some of the servos they have out there are, I mean, like I said before, they can be $100 a piece. And just picture if you had 20 of them in an animatronic, you're looking at a pretty high price tag there. And I'm working on this lip mechanism, and this is the axis point, and it needs to be correct so I can get the full motion of the silicone lips in the future. And even though that this is still on the bulky side, I can reduce the whole jaw mechanism, lips and all, and the teeth, and reduce the size of it so we could even just make the whole thing smaller. And these are the low poly teeth. And once again, I'm going to put new teeth on this design here, and I'll show y'all the process of how I do that to make an accurate bite. And when I mean bite, it means it will close according to the teeth. I mean, I had a lot of time in the dental lab making dentures, 30 years of making and I've made a lot of dentures, so I can make sure that some teeth are going to look real as possible. But as you see here, I kept working on the jaw. I just really wasn't satisfied on how the jaw was, you know, moving, and I had, and the other thing is that I'm trying to still keep it. I'm trying to still keep it like 130 millimeters from nose to the back, and I want to keep it that small, so when I have the skull on and have this whole thing complete, then I can put the skin on, and then adding the skin thickness to it, maybe around 150, maybe a little less. I'm still trying to keep it down so we can get this in at least a normal size large resin printer. I mean, I really wish we could print something on a FDM printer that would do the detail, but there's not too many FDM printers that will make I mean, it'll get pretty close. But the other option is print it on an FDM printer and then put a thin layer of clay on top of it and actually sculpt on top of that. And then that would give you know, that would give you more likely to mold easier, because silicone and resin prints don't get along. You have to do they have that issue of not liking resin prints where it kind of hurts the silicone where it doesn't. But there's ways of fixing that. But it's a process. But resin prints look good, and but I hear that they're working on fixing that issue. There's other developments of certain resins are going to be available to bypass that not liking resin prints with silicone, but there's other silicones you can use. But you got to also realize that when you mold things, there's shrinkage, but this silicone very rarely shrinks. I mean, it's micron shrinkage, but that's if you do a proper mix. But there's all kind of things we want it to work in our benefit. It's just that we have to work to make it work. I made this eyelid back a little thicker so I could put a plane in here and make a cut. And what I do is I make a component of a plane, and then you'll see here, and I'll join it, and then that way I can come back in here and I can just remove everything underneath that plane and make this flat. And I really like using this method, and I also use the same kind of method when I'm making before I print the final skull that holds most of all the axes and working components. I can just slice it right down the middle and print the top and print the bottom, but I'll print the bottom by inverting it, and that way I can print them on a flat plane. That way I can avoid those supports. But I really enjoy designing. You can kind of get lost into it, but you'll see me play around and what's next to do, and I'm thinking. But like right here, I'll just copy, mirror, flip on the red axis, and I have the shape. And then I'll take my measurement and see how the space. It's 77 millimeters, and then also I have to you have the brows and you have the eyes and you have the jaw and you have the teeth, and you got to make everything center. So I'll take this, for instance, on this design here, I'm actually making or finding the center point to this whole, I guess, modular section. I mean, you'll see me here. I mean, I'm always taking measurements because I just want everything to be square, center, and because if it's not, it can throw things off, and then you'll wonder why. But and if you keep the designs, like keep the eye mech one, keep the mouth mech one, and keep the brows one, and then you can join them all together. That way you'll keep things pretty much center. And this is in a design way, mirror it and just keep checking measurements. You'll see here's me working on this jaw here again, and I just keep mirroring it. And what that is, it benefits me, is that I sit there and I work on just one side, and then, but even though that this is going to be different on the other side anyway, because I'm going to be putting a servo on, I believe it's the left side's going to have a servo mounted to it. So I got to design a mount for that left side of the jaw. Now these axis points have like I believe it's like a 3 millimeter or a 440 measurement screw hole that like a threaded rod will go through this, and then I have it's just a design thing to make sure that I can get everything able to work easy and small enough to do it. Now here I'm mounting that servo, and I have a servo socket already designed. And what I'll do is I'll just line this up to where that hinge mechanism or the axis of the lower lip is lined up. So then later I'm going to design on that mechanism for the lip a linkage point, and then I'll have a linkage point to the arm of the servo, and it'll just be lined up perfect. But there's some days that you might notice that I didn't post a video. I'm trying to post a couple of videos, maybe 3 videos a week, but I'm going to try to keep up with that. Sometimes I might not be able to. I do have other animatronics that I'm working on, but I'm going to keep y'all informed. But like if you see here on this is the small mech here that has 2 servos in it. And this was the one that I put skin on. But this is the early design where with the mouth open, it pulled these rubber band springs or tension springs, and it made the lips move up. But this has 2 servos, and it has a rod going straight through to the other side, and that makes those eyes just straight. Okay, but I had to design it that way because how small it is, so I could make one servo blink all 4 lids. And this one here is the same way. This is The dark gray one is the one that is the newborn baby design, and it's the same way. And even though the eyes are close together, I design it that way because it's hard for me to put a screw on the inside or a nut on the inside of that because it's just so lack of space. But when I tilt the eyes, I'll be able to put, nuts there on, they're far enough apart that I can put a nut there and lock it in place, having a tilt mechanism like there for it. But this is what I've been working on, and this is what I got. You can see the size compared to all three of them together. But I appreciate y'all. Thanks a lot. Thanks for the support. Thanks for all the sharing and thumbs up. Later.